Hello and welcome to this presentation. My name is David Zwierzchaczewski, 3D Specialist for Media Entertainment at Autodesk. Today what I want to talk about is Stingray, which is a new game engine Autodesk has. What I'll be showing you is a very high-level overview of what Stingray is and what it's capable of doing. I won't be diving into too much detail. I'll be saving the more deeper dives into more technical stuff in later videos. Alright, so let's get started. So what is Stingray? Well, it's a very modern, very new game engine based off the BitSquid technology that was acquired about 2 years ago. It's quite tightly coupled with other Autodesk software, namely the 3D asset management tools like Max, Maya, Maya LT, and in the suites for quite a few years we've had the send to button. I'm sure you've seen that, where if you're working in Maya, for instance, you can hit the send to Mudbox and it'll send that file straight through to Mudbox. You can open up straight in Mudbox, work in Mudbox, and then send back into Maya. So that uses FBX under the hood to do that, and we've integrated that process with Maya, Max, and Stingray. So it's very that transfer of data and that backwards and forwards transfer of data is quite easy. Like I said, it's based off the BitSquid engine that was acquired a few years ago, but inside of Stingray now, we've also got other middleware software that Autodesk has had for a few years and has been used in varying degrees in a lot of other projects. So that's Scaleform, HumanOK, Beast, Navigation, WWise, and I know I'm forgetting one or two. One of the things that I think really separates Stingray from other engines is its workflow, and it's the way you can work very seamlessly, and the way you can iterate on the fly without having to compile data to see what something's going to look like before you play it. So like I said earlier, that ability to rapidly iterate is based off the ability for Max and Maya LT and Stingray to see each other and transfer data between each other very easily. What we've also got is other things like live camera linking, so we can make or move a camera in Maya, for instance, and then we can see that live camera move in Stingray. Another thing we can do is we can make changes to models in Stingray, and those changes actually happen in Maya or Max. We've also got shader effects for all your materials, so your physical based materials, or your procedurally generated or procedurally orientated materials go through shader effects. So you can do a lot of really good iterations, really quick iterations, because if you're using shader effects, like I said, it's procedurally driven, so changes are a lot easier to make. So this first example here shows the live linking between Maya and Stingray. So on the, just move this over, yep, so on the left hand side I've got Maya, and on the right hand side I've got Stingray. So what I've done is I've just live linked Maya's viewport to Stingray's viewport, and you can see now that as I move the time slider in Maya, the time slider the camera moves, and the camera also moves in Stingray. So here I am now just playing through in the viewport in Maya, and you can see that I'm getting that live linking and that camera moving one-to-one in Stingray. That's a little bit of jittering that's going on there. I think that's just the video playback, but this basically plays back without any problems at all. There you go. I think it's playing back a lot better now. So this next example shows more of that live linking between Maya and Max. So you can see here in Stingray, between Maya and Stingray. So you can see here in Stingray, I've selected the character, and then I'm just going to open that character in Maya, and you can see in Maya the character's sitting in a T-pose, which is the default setup for that character without any animation. In Stingray, we've got the base animation on that character, like just his idle sort of animation. Now, what I'm going to do is I just want to show how I can easily adjust the mesh without there being any real issue. So I'm selecting the character's head here. I'm just doing a soft selection, and I'm just going to scale that up and just move that a little bit. And then down on the bottom here, I'm just going to hit the update button, and you notice in Stingray, in a second, there you go, it's just increased the size of his head. So that really shows you how easy it is to adjust models and geometry in a 3D package, and then send that over to Stingray, and you can see that working in Stingray without it being an issue at all. So the next thing here is I'm opening up my material editor, and I'm opening up shader effects, because what I want to do is I want to use vertex coloring to basically paint on rust on this character. So just set that up here. Now I'm going to do like a vertex painting in the viewport, and anywhere I paint red on this character will actually show up the rust material. So you can see here I'm just painting over that, and this rust material is sort of coming through. So I've just got it on his chest there, yeah, just put a little bit more on him, and I'll just update that now. So if you have a look in Stingray, you can see now on his leg and on his chest he's got rust on him. So that's just showing you how quickly I can update the textures on the character. I'll just put a little bit more on there, kind of like this rust. There we go. So the next thing I want to show you is how I can set up the LOD on this as well. So I'm going to bring in a model that's got a much lower LOD on this. So you can see that model's come in now. And then what I'm doing is I'm just grouping that together. So it's all part of the hierarchy here, and skinning that to the already existing bones that are in there. And now what I'm going to do is I'm going to set up that LOD so it runs off the distance of where the camera is. So here I am. I'm just going into where the threshold for the camera is and the LOD attributes there. And as I move the camera in, you notice the high-res model comes in, and as I move the camera out, the low-res model drops in. So I'm just updating that now in Stingray, and I think that's come across. So as we move in, you can see. So you can see there I've just moved out, and it's a little bit hard to see, but just keep an eye on the leg. You can see the rust drops out. So the rust drops out because on the lower level of detail I haven't put any rust on there. So you can see that that sort of drops out on the character. So finally, the next thing I want to do is I'm just going to make a bit of geometry here. And on the character we've actually got a light that's sitting on his head. So we've got like an emissive sort of texture on there right now that's giving a nice little glow on there. But I actually want that glow to have a light that shines from there. So I'm just selecting the light here and just linking it to his head bone, so the light will move around with the head as the head moves. And then all I need to do is hit the update button, and then that light should come in, and there you go, the light's come in. So you can see the light is shining on that wall. It's a little bit hard to see, but you can see that that is actually linked and moving around. So what I'm going to do is just go in and just increase the intensity of this a little bit so you can see it a little bit better. Just do an update, and there you go, and you can see that the intensity of that light's a lot stronger now. So that's just showing how quickly the live linking and sending assets backwards and forwards between Maya and Stingray. we have a modern data-driven architecture. So what that means is, like you saw there, I can make changes very quickly and not have to compile the information to see those changes. It enables rapid iterations if you want to do rapid iterations. It also enables that sharing of data assets quite easily. So not only is the integration and asset sharing really flexible, but our rendering pipeline is really flexible as well with it. And this, again, like I said, enables simple and very quick debugging. This next video I've got here shows some visual flow scripting and how you can set that up. So this has been provided to me by some of the product guys in Montreal, so big thank you to them. And this gives you a little bit of an example of how you can set up your scripts with the visual flow system.
So here we have a pinball game, and I'm going to show you how to do flow-based game logic. So here, if I shoot these turkeys, the only thing that happens to them is that they light up, and that's about it. I wanted to do a few more things other than that. So let's open up flow, and this is the flow-based logic for the turkey. And you can see that right now the only thing that's there is this physics collision. So let's add another physics actor to this. So basically every time the egg is touched, I want you to play this node, and I want you to push the ball away. So anything that touches this egg will push the object away. So the only thing touching it will be the ball. So let's push it away, give it a mass of 20, hit OK. So we should be good there. The next thing I want to do is play a generic animation. So under animation, generic animation. So every time you touch this, speed of 3, just want to make it a little faster than what normally is. Blend time is 0.2. Let's pick the animation, and I do not want it to loop, so let's make that false. This animation was created inside Max, or you could also do this inside Maya, it doesn't matter, it's just a clip. And if I hit save, and ask me do I want to update that, I say yes. Now if I fire, you can see now the egg pushes the ball and the egg spins around. Next thing I want to do is every time I get the ball inside that middle hole over there, I want it to shoot out of the top two cannons, and you can see right now nothing happens. So let's get out of there. Let's make an event. So the first thing we want to do is zoom in and go to our create panel and create a trigger. So let's just draw out our trigger shape, and that shape, make sure it's in the right place because we want the ball to touch it. So that should be good. Next thing we want to do is we want to create the nodes to, every time the ball touches that trigger, we want it to bounce, or not bounce, but unspawn there and spawn to those other two cannons. I can go ahead and start doing that here, creating all the nodes to do it, or I can just go into my email and just copy and paste those nodes. So Control C and Control V. See, I just emailed, or somebody sent me an email of those nodes, and I just pasted them directly on here. So that's really nice that you can share flow nodes with friends. So every time this spawn ball touches, sorry, wrong one. So let's put that in here. So every time this spawn ball touches this unspawned unit, which is set off by that trigger, let's get that trigger that we just created. It will do a random event, and the random event will either play out a cannon 2 or 3, which is right here, cannon 2 or 3. So now if I go ahead and play, and my aim is any good, which it looks like it's not, alright, I'll get it eventually. There we go. see that the balls now spawn out of these two cannons up top. Next thing I want to do is I want to show how you can create a scripted flow node. So for example, here are touch controls for the iPad and the Android devices. And we had to create our own scripted flow node. So here, this is one scripted flow node. It's actually very simple to do, and I'll show you how that's done. Let's, oops, no, we don't want to delete. Let's show and explore, and we'll go into here. So this is get screen size. You can see get screen size. This is that flow node. I'm going to just hit Control C and Control V. So I just copy and paste it. Really, I didn't do anything special there. And I'm going to just rename this to underscore plus. And I'm just going to add another option, which is usually you only want XY, you don't want Z, because well, there's no Z depth for your finger pushing for controls on the touch devices. So, but anyway, this will just get the point across. So if I hit save, yes, I want to save, and if I go in here under project, you can see I just saved this, and it says get screen size plus. All of a sudden it gives me these two options plus the third one that I created over here. So interactively, you didn't have to restart or do anything fancy, it just updates it directly here. So really easy, you can create your own scripted flow nodes and not be stuck with whatever we ship with. So you can create your own very simply and easily.
Continuing on with the workflow, the file structure system is non-rigid and friendly to use, I guess you could say. Like I said earlier, everything you've seen so far enables that very collaborative environment. So what's great about this is it gives you that flexibility. So you can work on a small project, or you can work on a big project with this. So you have that flexibility of scaling up your pipeline as your project needs it. Deployment and testing are always something that's quite a time-consuming aspect of games development. What's great with Stingray is we've got that single-click deployment to platforms and that live linking debugging to target devices as well. So we've got some very powerful things going on under the hood here. We've got DirectX 11. We've got, for our rendering effects, we've got our physical-based shaders. We've got a lot of screen space effects that we can do. We've got Beast for our global illumination, Scaleform for our user interface and UI design, Human IK for animation, navigation for pathfinding, PhysX, and WYs for audio. So this picture here just shows you what you can expect to see in viewport. So you're getting very nice shadowing and lighting effects, basically, straight off the cuff. And you can see here in this picture, we've got some really nice light blooming effect happening, depth of field happening, shadowing happening. So this sort of gives you another good example of what you can see in camera. So in this video here, I just want to show shader effects. This time I've got Stingray on the left-hand side and I've got Maya on the right-hand side. So I'm editing the material editor in. So I'm editing the material editor in Stingray, and you can see those edits are happening in Maya, and vice versa. What edits I do in Maya, they transfer across to Stingray. So you can see I've just added a little bit of more of a metal sort of look to this guy. And then I'm just going to add some color to here so you can actually see his color come through. You can see there now I've got the red and all of that happening. This next video is a really good demonstration of some of the post effects that you can have in Stingray. So these are all in-camera post effects. So we've got lens distortions that can happen, which is really good for doing things like fisheye lenses, that sort of stuff, zooming in, zooming out, anything that you need to do some sort of distortions on the lens. We've also got this vignetting that we can do here, so we can well, as you can see here, we can blur out the edges, or we can shadow out the edges. And then if we combine all of these together, you can see this is what the final result looks like. So you can see we're getting a nice sort of zoom lens going on here, or a wide angle lens I should say going on here. We've got light blooming going on, we've got the vignetting happening around the sides here. And then just in a sec, so you can see now on the left hand side this is with all effects, and on the right hand side it's with all the effects taken off, and you can see the vast difference in the two. And then just finally, just another quick video just showing you with all the effects turned on. So we've got nice light bloom coming in, depth of field going on there as we pull out, distortion on the lens. So like I was saying earlier, that rapid development is a really important thing, especially if you're doing small games or indie-based games. And part of the thing that helps with that rapid development is the live connection or live linking that we've got. Now I showed you the live linking that we've got between your 3D asset creation tools like Max and Maya into Stingray, but we've also got live linking between Stingray and your deployment devices. So whether it be a PlayStation, an Xbox, an iOS, or an Android device. And in this video here, you can see we've got the game on the PC here, and then we've sending it over to an Android device, and it's playing on the Android device, and then we can also send it over to an iOS device as well. So right now I'm playing with it on essentially 3 different devices. I'm playing with it on a PC, on an Android, and on an iOS. And you can see that the different aspect ratios of the different platforms is actually causing a bit of an issue here. You can see that the more letterbox aspect ratio on the smaller device, which is the Android device, is allowing me to see the whole UI that I've got, where I'm actually getting that cut off on the iPad. So this is great. This way I can test across multiple devices simultaneously and see what's working and what's not working. Some of the technology that we've got in Stingray, even though Stingray itself is a new, relatively new engine, we've got some really big heavy hitters that are sitting in there. So we've got Beast, Human OK, Navigation, and Scaleform. And I'm just going to show a couple of examples now of them in action. So the first one here is Human OK. So what I've got is this robot guy walking over different terrain, and you can see just off this one walk cycle, his feet are always staying contacting to the ground. So as the ground has all this different stuff, debris, as long as I've set that up as a contact point, his feet will move over that. Now we can also do this, take this to the next step, and we can have an animated ground that the character is walking on. So you can see that the feet are always staying contacted to the ground, even though that ground is moving. So this is one of the great strengths with Human OK. Not to mention the the vast improvement and simplicity of rigging through Human IK as well, which opens you up for doing motion capture and keyframe animation really easily. Okay, so next thing is navigation. So what we've got here is just an example showing you how we've got a bot that's coming through this environment here, and I'm just dropping in random bits of debris that he has to try and navigate around. So you can see I've got a navigation path that he walks through, but that navigation path is changing on the fly, and so as it changes, this bot has to work out a new navigational path. So it's just showing you that you can build a very simple navigation path, which is this whole plane here, and then I can add complexity to that navigation path by having dynamic objects inside that navigation path. So like I said earlier, Stingray is a new engine, and there aren't really that many games as yet that have used it. These are a few that have. On the flip side, Scaleform has been used by hundreds and hundreds of games, and WWise has been used in a lot of games as well. So a lot of the middleware stuff that's sitting inside Stingray now has been used on a lot of games. But again, Stingray only came out a few months ago, and these are some of the games that have been made using it. Two final points I want to talk about here. I'm just going to touch on this. One of the things that's very close to my heart is real-time animation, and this is something I'm really pushing and driving to use game engines for rendering instead of using render farms for rendering for TV shows. I guess I could say watch this space. This is definitely something I'm going to be pushing heavily over the next couple of months, and this is something where I really do see Stingray taking a big lead in this sort of area. Another non-game related use for Stingray is in architectural visualization, and if you have a look at this bottom link I've got here, Project Expo has been designed to allow architectural people the ability to import Revit files into the game engine with minimal of fuss. There's still a bit of work that needs to go into it, but what Project Expo is aiming to do is reduce all that fuss, so you can almost go, it's almost a one button click import. It's not yet, but hopefully it will be soon. So if you are interested in architectural visualization, have a look at this link, or just remember Project Expo and go to projectexpo.autodesk.com to have a look at that. These are a couple links of where you can get a free evaluation for Stingray. The final link, the Creative Market there, that's a great place to go for getting tutorial stuff. It's also a great place to go to get assets if you want to make a level and you don't want to go through the rigmarole of making a character and doing animations, all that. There's already a lot of characters up there and animations up there. Alternatively, the Creative Market is also a great place for you to upload your assets if you want to sell them. So this is a great avenue for you as an artist to buy and sell assets for other artists to use. Now, the money conversation is something I always try and stay out of. I hate talking about money, but I just want to quickly touch on this because it is quite amazing, I think, how cheap it is. $45 a month, excluding GST, you get Stingray and MyLT. Now, you can get Stingray for $45 a month, or MyLT for $45 a month, or you can just get both of them for $45 a month. I think that's incredible. That's an incredible price. So basically, you have, with those for $45 a month, you have the whole. You have at your disposal all the resources you need to make a game. You've got all your asset creation tools. You've got all your animation tools. You've got audio tools. You've got your engine. You've got everything there to go. So enough said about how much it costs, but yeah, it's pretty ridiculous how cheap it is. Finally, these are my contact details. The last contact detail down there is our Facebook page, so you can find the ANZ M&E group. Just go to Facebook, type in Autodesk M&E ANZ, and that'll be the local Autodesk M&E group there. Okay, so thank you for watching this. I hope this was informative for you. And like I said, there will be other videos coming out later which I will dive deeper into Stingray and we'll talk more specifically about stuff. So thanks again for watching, and I'll talk to you soon.